So this next section is looking at angles that are made with vectors. We're also going to look at the dot product in the next section, which is a more useful formula for angle. But here we've got a vector that has three different components, the I, j and k, so in the x, y and z directions. You can find the angle that each of those components makes with their respective axes. So for example, cos of alpha, that's the angle that your vector makes with the x-axis, and that's the x component over the magnitude or the total magnitude of that vector. Cos beta is the angle that's made with the vector and the y-axis, and again that's the y component over the total magnitude, and cos gamma is for the z-axis, so it is the z component or the k coefficient A3 over the magnitude of the whole vector. And all of this is using Pythagoras. So it's a great exercise if you want to try that, to try and determine why this is the case. Okay, it is essentially just your Pythagoras and your trig, your cos, opposites and adjacents and hypotenuse that you're using there. So if we look at the example here, example 15, we've got two vectors. We've got the vector A, which is 2i minus j, and the vector B, which is I plus 4j minus 3k. And we're asked to find two things. First of all, we're asked to find the magnitude of those vectors. And again, we just square root the parts in front of the I is squared and the parts in front of the j are squared. So this would be the square root of 5 for the first one. For the second one, we're doing the same thing. So b, modulus of b, square root of what's in front of I squared, what's in front of j squared, and what's in front of k squared. You see that I use brackets just to make sure that I'm not forgetting to square the negatives. And here you can see that we 25, that's going to be the square root of 26. And there's nothing you can do with that. That is what it is. So they're the two magnitudes for those vectors. The next part, B, we're asked to find the angle the vector makes with the y-axis. So that would mean using this second formula, cos beta equals A2, which is the coefficient of j over the magnitude of the total vector, which also can be written as inverse cosine. Remember taking the cos to the other side of A2 on the magnitude of A. Oops. So we can use that, and that will give us our angle beta. So we can use that here in part B. So let's find for A. We know that this A2 that we'd be using is the coefficient of j, which is -1. The magnitude of A we know is the square root of 5. So this angle that beta, which is the angle that the vector makes with the y-axis, would be inverse cosine of -1 over root 5. Now this is where you'd be using your graphics calculator here. So we've got -1 over root 5. I'm going to put this in degrees. So to do that, go to Home and then go into Settings, Document Settings, and then just put that into degrees. Okay, and then back to current. So now we've got inverse cosine, and it was -1 over the square root of 5. Okay, and we just want an approximate, so we'll put that there. So 116.57 would be the approximate there. So all I did for the approximate is just Control and Enter just to get it out of that exact form. So 116.57. So 116.57 degrees. Okay. For the next part, for the vector B, again we've got a similar kind of thing. A2 is that coefficient of j, which in this case is 4. The modulus of b we know is square root of 26. So the angle that the vector makes with the y-axis would be the inverse cosine of 4 over root 26. And again, I'm just going to use my calculator for that. So 4 over root 26, inverse cosine, and let's do 4 over root 26. Again, I'd like this to just be an approximate, so I'll just put an approximate, Control Enter, and I've got 38.33. So 38.33 degrees. So I'll put that there as my answer. So 38.33 degrees. So that's the idea with finding vectors, finding angles of the vector between each of the axes, these three formula, and also a reminder of how to find our magnitudes for vectors.